Think you're special? One of a kind? We agree. The way you pursue your digital ambitions is unique to you. And so is your appetite for digital risk. Whether you're hyperconnecting your ecosystem, empowering a distributed workforce, rapidly leveraging cloud, IoT, AI, or other new technologies, RSA is here to help you manage digital risk your way at every stage of your journey. So go ahead, be you.
Hello and welcome to Building Safety, Security, and Resilience Through Chaos. If you're joining us live, our speakers are now in the Slido discussion answering your questions right now. For audio and video issues, please click the technical support button below. And I'd now like to turn it over to Aaron Reinhardt and Jerome Walter for the presentation.
Thank you and welcome to this session. I'm Jerome Walter. I'm the Director for Security Modernization at VMware. For the last 20 years, I've been lucky to have positions as developers, system engineers, and lately as security executive in various organizations. At VMware, I help companies who are embracing cloud and modern applications and agile methodologies to leverage those capabilities for security. Throughout the years, I've noticed that a lot of the traditional security approach tends to compensate for flaws in our practices and systems and inherently are limiting the business. In this presentation, I will look at a number of key principles for architecture for designing security from within that doesn't impede the velocity of your business.
Hi, I'm Aaron Reinhardt. I'm the CTO and co-founder of Vericon. I'm also Verica is a company that specializes in bringing the tools, the chaos engineering tool sets from Netflix and United Health Group to the market. I'm the former chief security architect at United Health Group. I have a background actually in safety and reliability engineering at NASA, as well as I was a software engineer for most of my career. I'm a frequent speaker in the space. I wrote the security chapter on chaos engineering, the security chaos engineering chapter in the O'Reilly book. We'll talk about that. And Jerome and I are also authors on the security chaos engineering O'Reilly book due to come out end of summer.
Thanks, Aaron. Most of the organizations today are facing with a challenge. On one hand, the digital transformation and the business needs innovation, needs to change. They are under a lot of pressure from new startups, from new organizations and technology companies who are disrupting the market. Companies want to improve their ability to innovate and improve their ability to change. If you read the news, however, you see that there are breaches happening every day. Security and assurance functions want more control, want more stability. And in the traditional practices, it seems to be a zero-sum game. On one hand, innovation needs new technologies, needs to step up on the latest game even before it is standardized, needs to iterate fast, needs to be lean. While when you look at the traditional practices in resilience and security, it's pretty fixed and stable. Disaster recovery planning, risk assessments set in stones, protective added-on security systems that actually slow the speed of change. If you look at resilience, which is a core capability today of our business, resilience engineering owners have pretty much said it clearly. The resilience of an organization is the ability to resist, absorb, and recover, and adapt to change. It's really whether you're resilient or not depends on whether your customers can depend on you in times of crisis. In times of COVID, we can see it. Organizations who are doing the best are the ones who are able to adapt to serve the customers who are in need of new support during this dire situation, not the organizations that are struggling to survive themselves. Whereas when I discuss with a lot of IT and security executives about resilience, the view is pretty much around building robustness in the system or the ability to recover from disaster. Agility and the ability to adapt is very often left aside. We've developed a flawed view of our systems. In our practices, we try to wrap our heads around the complex systems, and we want to document them. But the reality is often very different than what actually is written in the plan. If it wasn't, there wouldn't be any outage or any issues. Our approach also doesn't stand the test of time. When you build something, things change, organization reorganize, competition change, and the needs are always constantly evolving. Our systems have become way more complex than we remember them. We try to simplify them to wrap our head around it, but the reality is often much more complex. There is also a division in the organizations. On one hand, we have the builders trying to build new application and it brings this innovation. On the other hand, we have teams of defenders who are struggling and incentivized to improve the stability and to improve the defense. And for them to cooperate, we write plans, we write documentation, and we try to accentuate this issue of simplifying for everyone to be around the table. If you're familiar with Conway's law, you will know that all systems tend to reproduce the organization, and that's a key challenge we have today. The hope is not lost. There is a new playbook, new practices that come from organizations that have embraced the cloud technologies and embraced Agile from the last decade. And this is what I want you to look at with you. A few attributes are very important when you design your systems. We will see 3 attributes, DIE, to remember them, that really helps building resilience in your systems. If you want to build security without impending the innovation, you should focus on these 5 attributes, ideas, and we will see what they are today. Modern applications have pretty much embraced those 5 principles. Immutable systems, systems that are not changed once they are built, where changes are not done after building, but while building and replacing systems. Distributed architecture that enables resilience and security as well. The workloads and the mindset of how you design a system to be ephemeral, to work only a few minutes or a few hours instead of the old ways of doing years. Authentication is critical for increasing security, and so is segmentation to reduce blast radius of issues. Let's look at a few of the benefits. Once you build an immutable system, which means you're moving towards a declarative system, everything is written as configuration as code, infrastructure as code, and applications. Then your systems enforce what the state is supposed to be. You gain predictability, you gain auditability. You also reduce your chance of insider threats by removing the human change directly from the system. Distributed systems have been there for decades, and we know their value in terms of handling fault tolerance. But joined with the immutable principles and pipelines we have today, it also facilitates patching of security vulnerabilities in a matter of time. We see massive reduction of patching windows thanks to this approach. The real change, however, is the ephemeral nature of microservices. While in the past you were building something and trying to maintain it for years and years without outage, cloud-native architecture really think about workload as something you destroy and build regularly. What it means for security is that you can guarantee that the state of your system is what is in your configuration. You can wipe clean regularly to disrupt any cyber attack. Everything is API driven, so you need authentication to make sure that everything remains controlled by your users. Segmentation of networks and through service mesh really helps reduce the blast radius by making sure that your network segmentation is your business logic. We have a new challenge today. We're moving towards declarative programming, infrastructure as code, security as code. That means that everyone needs to focus on reconciliation of the state, making sure that the state of your system is what you expect it to be. And this is where we have today. In terms of tools, it's what Kubernetes and all those application platform really brings into you. Declarative manifest and making sure that whenever the state of the system changes, it is the platform resumes the normal state. Cloud-native security is the same, making sure that anything that deviates from the plan and from your configuration files is detected and resumed to normal. In terms of practices, declarative programming at the application level really helps this. Repaving your infrastructure, destroying and rebuilding regularly to make sure that it's clean of any unauthorized modification on malware is extremely important. For more complex reconciliations, though, this is where chaos engineering is so important. Simple practices really help give you the hygiene, but complex to find weaknesses requires chaos engineering. And I really want to leave you with one principle of the cyber hygiene we need to do today. Improving our ability to repair through pipeline and through immutability and through distributed aspects. Your ability to fix a vulnerability before someone exploits it is very much the core of not being breached. Repaving and destroying and rebuilding as often as you can to make sure that what runs in your environment is what you expect it to be is absolutely important. The more often you repave, the less likely a lateral movement will be able to be executed. Rotating your credentials is primordial as well. We see in the last Verizon report that 80% of breaches have to do with stolen credentials wherever they are. Changing them regularly and your ability to change them regularly can make the difference between an attack and a breach. Aaron, I leave it to you.
Thank you. So chaos engineering in general requires a change in mindset. And an important aspect that I love to bring to bear is that this actually statement is a modified statement from Sidney Dekker, which replaces the word secure as safe. But it's a reminder, like when things go well, humans are involved. When things go bad, humans are involved. And no system is inherently secure by default. It's humans that are required to make them that way. It's safety, security, liability are human constructs. It's important to remember that next time we point the finger at a human error and things like that. So what is this chaos engineering thing I keep talking about? If you haven't heard about it already, by the way, I often ask people if they've ever heard of chaos engineering. Some people raise their hands, and I ask people if they've ever heard of Chaos Monkey, and more people raise their hands. It's the same thing. And the Chaos Monkey is a tool within chaos engineering. So what is chaos engineering? So the Netflix definition is it's the discipline of experimentation on distributed systems in order to build confidence in the system's ability to withstand turbulent conditions. Another way to think about it is the idea of proactively introducing turbulent conditions into a system to try to determine the conditions by which a system will fail before it actually fails. And we'll talk about how this applies to security, but in general, this is the basic concept. We like to label it as more experimentation than a testing regime. Who's doing chaos engineering? It's a little over, I think, 12 or 1,300 companies now doing it in various shapes or forms of it. And security chaos engineering is taking off as well. It's been quite interesting to watch. But this is no longer a fad. This is becoming a standard practice, and eventually it's going to be part of the new normal. So there are currently 2 O'Reilly books out on chaos engineering. The first one was from Netflix. The second one was written by my co-founder at Verica, Casey Rosenthal. That's this book I showed up earlier, just came out. It also has chapter 20 is the chapter on security chaos engineering. And as a reminder, there will be a full book on security chaos engineering towards the end of the summer coming out. No chaos engineering story would be fit without explaining Chaos Monkey. So Chaos Monkey was the sort of beginning of chaos engineering at Netflix, and was born out of actually Netflix's cloud transformation. A lot of people forget that key component, because a lot of people say, Aaron, I can't even do the DevOps. How am I going to do chaos engineering? Well, Netflix was very immature at engineering as well. It was during their cloud transformation from DVDs to Amazon that they conceived the need for it. The idea is that what was happening is as they were building in Amazon, AMIs, Amazon Machine Images, would just disappear. It was a feature at the time of Amazon, apparently. Well, what they needed is after they built their systems to be resilient to that particular problem, they needed a way of actually testing it. So Chaos Monkey, during business hours, will pseudo-randomly select an AMI, it will terminate it. And what that does is it puts a well-defined problem in front of an engineer. What do I mean by that? Well, any engineer has the condition that that can happen in my service during business hours. So I need my service to be resilient to those kind of failures and problems. It turned out Netflix did, and the story kind of evolved from Chaos Monkey. But a key thing is that it's really about putting well-defined problems and context in front of engineers. What is security chaos engineering? Well, I'll cut to the chase real quick on it. It's really the same thing as applied to security. It's just a different way of thinking about it, and the use cases are a little different. A core premise of chaos engineering in general is that hope is not a strategy. I've kind of evolved my statement here is that engineers don't really believe in two things: hope or luck. It either works or it doesn't, and we want to know why so we can make it better. Yeah, hope worked. The hope as a strategy worked in Star Wars, but doesn't work here. So it's really about continuously validating that our security functions the way we think it does. A lot of companies that have come to me and I've helped them get started with security chaos engineering, they've started applying these techniques of injecting these failure modes into their systems, and they're finding that a lot of their security actually doesn't work. But that's great. I mean, it's better that we proactively find out that our security is not functioning as well as we think it is. It's better that we find it out instead of an adversary taking advantage of it. Through the process of using chaos engineering, we're able to reduce uncertainty, because if we're constantly injecting things like misconfigured ports or permissive accounts or turning off encryption, or if we're constantly injecting the things that we expect to catch, we build this confidence that we know under certain conditions that and we constantly do these things that our security is functioning as good as we wanted it to. And that builds a great amount of confidence. And we really need that in the business. It's really about proactively managing and measuring, because we're initiating the event. Instead of waiting for an event to happen, we can now kind of measure things like incident response, and we can measure and look at logs and see if the log data actually made sense. If you're trying to evaluate log data for areas during an incident, it's a little too late to be doing that. If you're proactively injecting these failure modes and trying to determine, hey, did the environment give us the right kind of data we need to understand what happened? It's way better. It's a way better learning environment when people aren't freaking out during an incident. The cognitive load between handoffs is too much for a learning environment. So some of the use cases for chaos engineering, incident response is a great use case for chaos engineering. Obviously, control validation. Validating the security controls fire under the conditions you expect them. You'd be surprised when you start doing this to find out that they really don't. But that's not due to anybody intentionally doing that. It's the size, scale, speed, and complexity of how we build things. Our controls quickly drift out of effectiveness. That's chaos engineering is just a way for us to know about that, fix it proactively. That's a key thing about chaos engineering. It's a proactive technique. Instead of most other techniques are reactive. Also, it's another use case is security observability. It's a great, like I said, it's a great way to find out what log data you had or log data you didn't have, and enhance your observable events during those types of signals. Also, compliance monitoring. Every chaos engineering experiment, whether it's availability or security-based, has compliance value. Essentially, you prove whether the technology works the way you thought it did or how you had it documented in your compliance. And so there's compliance and audit value for every experiment. So the incident response use case is really a valuable one. And because no matter how much money you spend, how many people you have, how many fancy new security controls you have, you still don't know a lot about an event. Is that you don't know where it's going to happen, who's doing it, why they're doing it, how they're trying to get in, or who it is, and so it's difficult. It's hard to compare. Also, subjective events side by side, and you're also assuming that you knew the point of which the event began, or that it wasn't a cascading event from multiple things. But when you initiate the event yourself, you're able to now kind of manage and measure. Did I have the right number of people on call? Did they have the right skills? Did they have the access they needed to those systems? Were the runbooks correct? These are the kind of things you can do with chaos engineering that you couldn't do with other techniques. It's really about flipping the model instead of post-mortem being that exercise that's really about explaining to management what happened. It makes the post-mortem actually a preparation exercise, is that we get to proactively introduce these conditions, figure out what worked, what didn't. If it didn't work, which almost every chaos engineering experiment I've experienced doesn't work the first time, but if it didn't work, document why, develop an understanding, talk them through, develop a remediation, and then run it again, right? And we're doing this when there's no incident or outage. We're discovering things about our system we didn't know. Because if we knew them, there never would have been the outage. We would have just fixed it. And just remember, we don't do chaos engineering when people are freaking out. This is a proactive methodology to discover and build a continuous learning capability within our engineering apparatus, but we don't do it when people are freaking out. So Chaos Slinger. So I'm sort of known as being sort of the pioneer behind applying Netflix's chaos engineering to security. And I did it at United Health Group, and we wrote this tool called Chaos Slinger. What it was is the first ever application of chaos engineering to security. But I'm no longer at United Health Group, but the tool is out on GitHub, and basically it represents a framework for how to actually execute chaos experiments. There's 3 functions, and there's a couple example experiments out there, and there'll be more on this in the O'Reilly book on the how-to and all that. A few other features of the product is it's entirely Lambdas in AWS. It only works for AWS at the moment. It's a ChatOps integration, and it's an opt-in, opt-out model. So an example experiment that we released with Chaos Slinger, we needed an example experiment that everyone could relate to. And the example experiment was Port Slinger. Port Slinger the failure mode was an unauthorized and misconfigured port change. And for some odd reason, it happens all the time. Not intentionally, people either fill out the form wrong, they either apply the change wrong. It happens, right? Well, we started doing this and running this on our AWS instances. We started finding out that our expectation was that our firewall would immediately detect it and block it. It would be a non-issue. We found out that was only true about 60% of the time. So that's the first thing we learned. The second thing we learned was the cloud-native commodity configuration management tool caught it and blocked it every time. So something that we're kind of paying for wasn't as good as the thing we weren't paying for. So anyway, we were able to proactively fix. We had a configuration drift issue between our different environments for the firewall, so we were able to fix it. There was no incident. Also, we expect a good log data to correlate an event to our security operations center. That happened. That actually happened. But when the security operations center got the alert, they couldn't tell which Amazon it came from. And as an engineer, you can say, well, you can take the IP address and map back which account it was, but that could take anywhere from 30 minutes to 3 hours. And during an actual incident, that could be millions of dollars that you're losing. Well, millions of dollars weren't lost. We just realized we had to add a pointer, and we were able to resolve the matter, and it wasn't a problem. This example sort of illustrates the basis behind what we're trying to do. Let's see. And a few takeaways of this presentation are that, like Jerome talked about, security by design with IDEA and DIE. Jerome has really evolved a meaningful sort of extended DIE framework with ideas. DIE was also the person who created DIE is another author on the O'Reilly book, Sunil Yu. Also, security chaos engineering provides a proactive measure for verification of our security controls. It's really about validating like how things really work versus how we think they work. And we find that like Jerome talked about earlier, is that systems engineering is a very messy exercise. We quickly, because of unforeseen events, our systems become stable through unforeseen events and incidents and outages. Because we learn about what didn't work and we fix it. But why encounter the pain? Chaos engineering allows you to be proactive, so you don't encounter the pain. You proactively learn, service it, fix it, and repeat. And it's important to instrument your security before someone else does. And that's really also what we're trying to do before an attacker has an opportunity to take advantage of it. And lastly, resilience is not something a system has. It's something a system does. Jerome?
Thanks, Aaron. And if you think about it, a lot of the discussion towards increasing agility and DevOps focus on this mean time to recovery. But in security and resilience, we also have an issue of mean time to detection. And that's really the core of why chaos engineering is so important and security chaos is so important. In the times where everything changes, the stale playbook and the stale documentation do not help. So many times we see SOC who struggle to build context and know whether it's a breach or not within the first few minutes or hours of an incident. This is really where teams need to work together, and chaos engineering is a way to get them practicing and get them comfortable with this approach. But it doesn't work if you don't do anything about it. So we'd like you to take away and apply it forward. And we know it's a complex program. You won't just apply chaos engineering on absolutely everything tomorrow. But what you can do, though, is share this concept with your teams. Look if you have an SRE, a site reliability engineering in your organization, and try to identify a few security scenarios you could work out with them. In the next 3 months, please read the book. There will be much more details on patterns and how to get started in this book than we can cover in this presentation. Review your user-facing application and review your ability to repave and rotate those credentials. This is extremely important as a disruptor of a kill chain. So please assess your ability to do it. Pick an application and run a scenario. It can be manual first. It's not an issue, but just run a security chaos engineering scenario to get comfortable with it. And then in the next 6 months, start in automating some of the exercises so that you can apply this continuous verification in everything that you're building and deploying. This is really an important step and an important turn in the way we do resilience and security. A move towards static test towards, a static test towards continuous verification. And we really would like you to get on board with that. Thank you.
Thank you, everybody.